doing DeFi, greatest in the world, and they finally about to see why. What you know about XRD? I'm smart money, I ain't never on a decline. What you know about NFTs? It's not just Ace, when you finally gonna realize you need scalability, need more utility, then you better call on these guys. I'm going radical, I'm going Radix, I'm going radical, I'm going Radix. Hyperspeed DeFi, never on a decline, building the future, I feel like a savage.
Hello and welcome. I am Piers Ridyard, CEO of RDX Works, a core developer of the decentralized finance protocol Radix, a public ledger entirely focused on bringing DeFi into the mainstream. This is our podcast, the DeFi Download, a show about decentralized finance and all things crypto, where we dive into the details of the projects, assets, and services that are powering the DeFi revolution. Today, I'm joined by Brian Pellegrino, co-founder and CEO of LayerZero Labs, which has built LayerZero, a generalized cross-chain messaging protocol, as well as Stargate, a cross-chain liquidity transfer layer. Brian, thank you so much for coming on the show.
Absolutely. Thanks for having me.
So let's break those down into super simple terms. What is a generalized cross-chain messaging protocol, and why does it matter?
Sure. So when we started this, actually the reason we started this was everybody before, there was no way to do the very simple thing of have something live across two chains. So the inception of this was us, the heart of technologists. We were just building a little game across two chains. And what would it look like as Binance Smart Chain was kind of taking off? We realized you actually had to have a central coordinator that sat outside and triggered events on both contracts. There was nothing that you could do about it. And we said, okay, well, bridges exist. So surely there's some way to solve this. And we went and looked at bridges, and we were both horrified by their security properties at the time, which has proven true, unfortunately. But also, they were really limited. Everything was strictly value transfer. And so we thought about it for a while, and we realized that value transfer is just a special case of a generic message. And so, our background way back at this point, 17, 18 years ago was IEEE testing and conformance, very early stages of internet technology. And we're just thinking about the primitives of the internet. A lot of this new systems, but a lot of these things have been solved before. You look at the primitive of a packet on the internet. It's very simple. You're just taking a small piece of data and passing it between computers. But then what you can do with that simple thing is near limitless, right? Now we're talking now over this, and you have Netflix and everything else that has happened, right? So LayerZero is really, that's all it is. It's this core primitive that is just passing data between two smart contracts. So it's coordination between contracts, general messaging.
Yeah. And why does that matter in today's world? And why are you doing something that is better than what you're currently seeing as the way of essentially moving assets between chains?
Yeah, sure. So why does it matter is really interesting. It depends on what you think the shape of the world will be. And I think if you look at even the most sort of staunch and ardent defenders of their ecosystem. So let's take Vitalik and Anatoly, right? Both of those strongly believe that they will not be the only chains that exist, right? And so there's these worlds where there's lots of different layer ones with strong kind of orthogonal trade-offs. And you can imagine a world where maybe you're using Arweave for storage and Solana for computation and Ethereum for whatever, right? You're using sort of leveraging each of these. There's another world where Ethereum is a settlement layer and there's 1,000 layer twos. And so there's all these different outcomes of what that might look like. But in all of these cases, in a world where somehow it's just Ethereum as a settlement layer and a ton of layer twos, you still need horizontal composability between these layer twos. A great example of this is Arbitrum. Arbitrum is just splitting into Nitro and Nova. It took me a minute. So basically a DeFi chain and a gaming chain. So we're getting into more specific instances of chains. And imagine you're on the DeFi chain and you do something, you trade, and now you want to go play a game. Is there really a world where you're going to wait 7 days and go out and come back? You need horizontal composability. And whether it's Celestia or Avalanche or Polygon or anyone who's trying to go horizontal, you need composability at that layer. But at the same time, you want access to services. You might be on Radix and you might be on Ethereum, you might be on wherever, and you will have the possibility where maybe a trade that you want to execute actually is a better execution price, like on Serum on Solana, or you might be on Solana and it has better execution of whatever you want to do on Radix. And like the ability to route between those and execute in preferred execution environment and then route out is like also super interesting. So I think there's a ton of cases where this is interesting, but yeah.
Right. So you're basically talking about the ability for a smart contract on one ledger to speak to another smart contract on another ledger, ask for it to do something, and then that smart contract then to return. So an example being, I'm on Radix and I want to trade. I'm going to borrow off a lending protocol on Radix. I'm going to trade across Uniswap v3 because there's great liquidity on Uniswap v3 on Ethereum, and then I'm going to get the return from that back onto Radix again into my wallet. So as a user, I never even left the Radix ecosystem. I borrowed something and then I got the return of what I expected as the outcome, but I never even touched the Ethereum ecosystem. Now, one of the questions you're going to get about that is, well, what about gas fees? So how does that work? Because there's some costs that are associated with that user doesn't have the assets for.
Yep. Yeah, absolutely. So one, like we can't not trigger an event on a chain. So one of the nice things about this is state always exists. There isn't like, there's, imagine you're holding state somewhere else. You're running this problematic case where, okay, you've sent a bunch of messages, state is held here like externally, and then like something happens here. And now those messages are gone forever. And that's like a pretty terrible case. Right. And so one of the nice things about this is like LayerZero is basically, arbitrary contract invocation between two contracts on two chains. So you write state on chain A, and no matter what, that state exists there forever, and it gets moved to chain B. The nonce is burned. It can only ever happen once. Something happens on chain B, and then maybe you come back and maybe you don't. So like if you're transferring an NFT, you don't actually need to come back. You might say, listen, I'm on Polygon with my NFT. I'm going to bring it to Radix. I lock it up here. I mint my new one over there. Polygon doesn't need like a confirmation that this has happened. But in cases where you're routing, like DeFi, like you were saying for the trade, then yes, you would. But at the end of the day, you're going to need to have, in the case you gave, a contract call on Radix and a contract call on Ethereum. So in that case, you will pay Ethereum gas. So it's going to be used when, if you're doing, I don't know, a $1,000 trade, then it's very likely that liquidity with the Radix is possibly sufficient, right? If you're doing a $10 million trade, then Uniswap v3 may get very attractive, and like paying a gas fee is effectively nothing relative to the amount of slippage that you save. And so it's really case specific.
Yeah, and so where does that gas cost come from on Ethereum? From the Radix user's perspective, am I also having to have an Ethereum wallet and pay for the Ethereum gas fee on Ethereum for that call?
Yep, no, that's something super cool within LayerZero is you only ever sign one transaction ever, and you only ever pay gas and source gas. So this unlocks a lot of really interesting things. So one is that as a user, if you want to come, let's say you're coming from Ethereum and going into Radix, one, you don't need to have already set up, like you don't need to have gas on Radix already, or you don't need to have gas on whatever the destination ecosystem is. Your whole transaction flow is executed. And if the user is landing there to do something, you can optionally pay. So let's say you pay $3 more upfront in Ethereum and get $3 worth of gas on Radix. So now when you land, you already have the gas to play around. You've been airdropped. You can do whatever you want in the ecosystem. But the other thing that people haven't really started to explore yet that I think will absolutely happen is imagine you're just a Radix user, like for whatever, clean, you have some experience where that's your wallet, that's your home base, and you want to do things on other chains, but that is where you live. You can actually, you don't ever need to have an Ethereum wallet. You don't ever need to have anything. Like all of this can be done through virtual accounts. So you could want to buy a Bored Ape that is on Ethereum, and that can just be held in a smart contract that basically your keys unlock. So this is held in virtual accounts. You can trade on DEXs or on like perps, right? DYDX or any of these others. And you can do all of that without ever leaving your home ecosystem, which is super interesting.
That's super interesting, but like, how does it work under the hood? Where's that gas coming from? How do you go from, for example, Radix tokens to ETH to be able to pay the miners on ETH?
Yep. So the relayer. So you have, again, transactions committed here. You need to invoke some contract over here, but state still needs to be moved, right? The chains themselves aren't communicating. And so you have these components that are doing this, one of them being the relayer, who takes the transaction proof out of a full node, submits to the destination chain. But the relayer is also responsible for this concept of gas abstraction. So the relayer is quoting you on source chain units. So in this case, the price of ETH in units of Radix. Right. And so you know ahead of time. So you never want to have this scenario where the user does something, gets there, and there's been volatility, something has happened, and they're like, you don't have enough money, or the price has changed, or whatever. So all the users should know ahead of time. So the relayer quotes and guarantees upfront exactly what the cost of gas will. You say, I need 300,000 gas on Ethereum. You pay it upfront. The relayer submits it on the other side. So the relayer deals with all the messy complexity of like managing gas of all these different chains and keeping those balanced and doing all of that. But that means the developer and the user don't ever need to think about it.
Right. Okay. That's super cool. So let's talk a little bit about the relayer network, because that's a core of the LayerZero. So how do you become a relayer, and how do we make sure that what the relayers say between ledgers is actually honest?
Yep. Yeah. So the relayer side, both everything, relayer, Oracle, all totally open and permissionless right now. So anybody can do this immediately from day one. It's always been that way. Now, one of the differences is that in most existing systems, you have this concept of a network of relayers, which you have issues potentially with Sybil, or you have some round robin selection, or something is happening where you're trusting some broad consensus. With the LayerZero side, the point was that we didn't think that could ever scale. So now you have this spread of relayers, a spread of oracles, and applications are basically opting in to choose a selection or subset of these. And so what that does is you might have Chainlink as an oracle, and say everything routes through Chainlink, or everything routes through any oracle. We'll just say a generic oracle. And maybe it's really secure, and it takes $2 billion to break. And if you finally break it, you could affect like $5 billion worth of damages. Right. And maybe one day this is going to happen, but that's basically about the cap, right? If that thing is securing $500 billion, then there's like very strong economic incentive for this to be broken. And so what you can do is you can take that same oracle construct and spread it across, connect it to 10 different relayers. So now, even if the oracle is broken, is malicious, is colluding with relayer A, now even if they do that, they only win this very small slice of exactly that oracle, of applications using exactly that oracle in relayer A. So anybody using any other relayer, anybody using any other oracle, anybody relaying their own transactions are completely unaffected. So the risk has effectively become sharded, such that the effective cost of the attack at the oracle above now becomes higher, significantly higher, based on the spread of risk across these relayers. But more than that, even that, right? Small applications, medium applications, they're like, listen, Chainlink is my oracle, Coinbase is my relayer. I'm totally fine like externalizing or pricing the risk that Chainlink and Coinbase will not be simultaneously malicious and colluding against my application. But your largest applications in the world are not comfortable doing that. They're not going to. And so the whole point of this... Let
me just break that down a little bit, because I think there's a couple of concepts that we've introduced simultaneously. So there's the LayerZero relayer network, which is a LayerZero construct. It's part of the actual protocol itself, and anyone can come along and they can run a LayerZero node. And the LayerZero node's responsibility is to relay messages between two target blockchains that are integrated. And what you're saying is, to make this scalable, what I think you're saying is, to make this scalable, what you need to do is you need to select subsections. So for this message, it's going to go to this subsection of nodes that have said that they're available to do relaying. And then that message is then relayed by those relayers to the other blockchain. However, the thing that LayerZero has done has gone, well, instead of going down the route of going, how do we make sure that these relayers are as secure as possible, and put a consensus system in there, and put tokens in there, and put incentives in there, like in the form that Ren would be, or the other bridges that sort of are common, like AnySwap. Instead, what you're saying is, hang on, there is another primitive in blockchain, in decentralized ledger technology today, that already has a degree of trust associated with it, that we can use to create this mechanism that is a lot harder to collude, and that is an oracle. So Oracle services already exist. They already are central to many DeFi applications. So, Chainlink is behind the price feed that comes from Chainlink is controlling millions, if not billions of dollars worth of assets on top of Ethereum and other chains. And Chainlink spends a lot of time and effort thinking about how can I secure their oracles and the data feeds that those oracles are responsible to. And so the insight you guys came up with was, well, instead of focusing on the security problem as just an intrinsic problem to our system, what if we were able to borrow the security of other systems that are also highly scalable and then create this problem where, from an attacker's point of view, they would have to attack both networks at the same time, both the Oracle and the Relayer network, to be able to cause something to go wrong. And the examples you were saying is the cost of attacking Chainlink is very, very high, been around for a long time, been established for a long time, and it has a vested interest in making sure that every single piece of data it puts onto any ledger is correct. And then from the Relayers network's point of view, there's also an incentive to make sure that the majority of them are honest. So not only do you have to be able to be the right subsample for a particular message in that network, you also have to have compromised the Oracle service that is the check and balance against the messages that are sent across. And I think I'm missing just that one piece of information, which is that if a message is set from one ledger to another, in the receiving ledger smart contract is required to check the Oracle service to see whether or not the message that the Relayer network is saying is coming from chain A is in the block headers of chain A, which is being reported by the Oracle service to chain B, right? Have I got that right?
So basically, broadly, there's a couple of caveats that I'll add. So one, yes, the two systems, Oracle is basically providing a block header, which has a receipts route. Relayer is pulling a transaction proof, providing that. You do the Merkle inclusion walk on the destination chain, which says, is this thing that the Relayer provided, does it match the route that the Oracle provided? Is this a valid MPT proof? And so, yes, on that side. One of the other reasons, though, there's two more components, is one, we wanted to make it totally modular for the reason that one of the problems we have with existing systems is everybody needs to opt in the same set of security parameters, right? So you have like one single point on a line that's basically cost and security. So every system you just put on a line, and here's how much it costs, here's how secure it is. And one of the big problems is you take two applications. One is Aave processing, $100 million liquidations, and one is Krabata dealing with 10-cent crab cake NFTs, right? And I love Krabata. I'm being a little bit tongue in cheek here, but right, just very different needs in terms of what they possibly are willing to pay for these things. And so when you force them to both opt in the same system, either somebody is wildly overpaying for security or somebody is not getting nearly enough security. And in most cases, both are extremely out of balance. And there's even scenarios where a single DEX. So take Uniswap, right? If Uniswap is processing outbound swaps across chains, there's a world where you say, hey, listen, any swap that's $10,000 or less with an aggregate outflow of, let's say, $1 million every 30 minutes, we're willing to actually be kind of down here. Let's only use 3 block confs on Ethereum because there hasn't been a 3 block plus reorg in 7 years or something, however long it's been. So we'll use 3 block confs. So we'll use a configuration that's slightly cheaper because nobody's going to reorg the Ethereum blockchain or attack this for, less than $1 million, right? Whereas if you're doing $1 million plus transactions, maybe you use 35 block confs and use something that's here. So the whole point of having this system be modular was such that you basically create this Pareto frontier of cost versus security where different configurations. So Chainlink is one Oracle, and maybe it's here in security, but it's over here on cost. And you might have someone else that's here, and that might be more appropriate for a different application. You can now you can have things that are, so all of this is done through library versioning. You can have a library that does batch validation. You could have something that does ZK attestation of a batch of things. So governance votes is a great example of this, where you don't necessarily care about timing as long as it's all submitted within, let's say 30 minutes before the vote ends, and you don't actually need everything to be sent ad hoc. You can bundle them up, batch them, and do one single transaction on the destination chain. And you can do this through snarks or other things. You might want, there's a bunch of things that you could want, but the modularity of the system allows this frontier to exist such that applications can opt in where they want based on the configuration of oracles and relayers that they're choosing. And then the only other thing I'll say is that in the extreme case, so let's say you're the biggest stablecoin issuer in the world, right? And you're responsible for like $100 billion. You might say none of this is enough. No system exists. I want to have my own say in how this happens, right? Maybe I want to have a signature. I want to own one of these components. So that was a point of LayerZero, is that you have the ability to own one of these own components. So if let's say you're Circle and you run your own relayer, then even if 100% of other network participants are malicious, there is nothing that anybody can ever do to corrupt it. You have zero unilateral ability to rug your users. Your users don't need to default trust to you, but you have veto rights on everything. So you don't need to trust any other part of the system. You can always veto. And that itself is hugely powerful when you're talking to like the large scale applications.
That's really, really, really cool. So basically you have this ability to add additional trust into the system for specific requirements. I think there's an interesting point here, and this is what why we'll go on to Stargate as well, is that LayerZero itself doesn't actually it doesn't bring any assets between the ledgers, doesn't do any of the things that we're talking about. From just a LayerZero point of view, if this application over here on Radix wanted to talk to Uniswap on Ethereum, then the Radix application would have to integrate, to build the calls that it wanted to do across LayerZero to the Ethereum ledger and the returns that it would expect on the other way, so that you essentially have a per application implementation where you go, okay, well, I care about this application here speaking to that application on a different ledger. Now, that's not with some things that makes a lot of sense, especially if you're trying to do multi-chain of the same application and allow that application to essentially feel like one user experience regardless of what chain you're on. But for assets, you kind of want a more generalized approach a lot of the time, right? You want to just, I have an asset, it exists on many chains. I just want to be able to arbitrarily move it between different chains. And I don't necessarily want to wait for the applications to have integrated themselves with LayerZero for the particular calls for the things that I care about. So I think this is where Stargate comes in, right?
Yeah, so the main purpose, we realized, okay, general messaging, super cool, tons of things you can do with it. But if we don't provide a liquidity transfer layer, then it will be 6+ months before people start to build the Legos that allows all the DeFi to be composable. So a very simple example is Stargate solves this inventory problem. You're a yield aggregator. You want to unstake $100,000 on chain A in some farm on chain A and stake it in some farm on chain B because it has 3 times the APY. On a single chain, it's fine. You unstake and then you stake. Across 2 chains, you unstake 100,000 USDC here, but you don't have 100,000 USDC here to stake, right? And that's the problem. So all these systems, whether it's SushiSwap or Pancake or yield aggregators, right? They ran into this problem of you do something here and you want to do something there, but you don't have inventory. So users would swap on Sushi, leave, find an external bridge provider, end up with a wrapped token, unwrap it or do a swap to that, and maybe make their way back to Sushi for the other leg of the trade, right? The ideal user experience is clearly sign a transaction and the whole flow is executed. So Stargate solves this inventory problem such that you can treat USDC on Ethereum exactly the same as USDC on Avalanche. So now you're a yield aggregator and you say, I want to unstake here and stake there. You compose Stargate in the middle, done. User signs one transaction and magically their money is in that farm on Avalanche, farming away, getting the API that they want, APY. So, what's happening behind the scenes is unstake, add to Stargate, subtract to Stargate and stake. But Stargate basically is that liquidity transfer layer of just abstract away liquid inventory and solve that for the applications. And so that was Stargate's entire purpose. And actually, ultimately, it's a cleaner way to do this. So Stargate's amazing in that, we within 2 weeks of launching, I think we were the fastest growing DeFi application of all time. We had $4.4 billion of stables. We had all of this fun. So we have really deep liquidity that we're able to move around and do all of these things that we're talking about. But, let's say there's a world where you're a stable coin or a Stargate token itself, interestingly enough, does not use the Stargate protocol, because Stargate token was built on LayerZero such that all of the supply is managed at the contract layer. The state is held in the contracts across all 7 of these chains. And so that supply is completely elastic. If you want to go from, Ethereum to Polygon and then Polygon to Binance Smart Chain, it doesn't matter, because all that you do is basically just burn here, mint there, burn there, mint there. The total supply is elastic. So that means you don't need any standing inventory, because you can now move all of that. So in the world where like a stable coin, was built on the OFT. So, and this will definitely, this will happen for sure. But in the world where this is happening, where stables, where other tokens are, now you have the ability to move $100 million from Solana to, whatever other ecosystem for only the cost of gas. So let's say you're going like Solana to Avalanche, you can move $100 million for 8 cents. And then that gives you the ability to basically arb spreads between pairs. So you're no longer paying 4, 6, 8, 10 bips to any external bridge. You're no longer needing to go through wrapped assets and carry those risk. Right. Now you have the ability to freely move that around, which just will make the capital efficiency of markets so much tighter, which also is super interesting.
So where's the token contract then? Is it the token contract on every single ledger? Right. Okay. Fine.
Yep.
So, but you're talking about inventory here, which means that Stargate and obviously that makes sense, right? If I've got USDC on Ethereum and I want USDC on Avalanche, if you're not actually wrapping it, then there has to be, if you're putting USDC in on the Ethereum side, there has to be some pool in which you're pulling USDC out on the Avalanche side. So how does that liquidity emerge, and how do you basically pay the people who are providing liquidity enough to be interested in doing it in the first place?
Yep. So Stargate, exactly right. Pools of liquidity on every single chain. You need to incentivize those pools. So one of the big thoughts of Stargate early on was that renting liquidity in perpetuity sucks. So the goal has always been grow protocol-owned liquidity as much as possible. So Stargate has about $150 million of protocol-owned liquidity. So it has a lot of its own liquidity. And then it rents the rest. And over time, through fees, through everything else, it's growing the protocol-owned liquidity such that it needs to rent less and less, and it gets to own and maintain more and more of the fees that are being generated on it. But right now, people are basically being paid in Stargate token or rewarded in Stargate token for providing LP of USDC, of ETH, of USDT, of all of these stables across these chains. And then the users on top are paying 6 bips on every transaction that go to these people who are providing LP. And so that is sort of where the pool TVL comes from right now.
Okay. So until people start the process of issuing tokens where the supply can be managed cross-chain, where you can simultaneously burn on one chain and mint on another, which you can with the Stargate token, but no one has yet sort of push that out on, say, a major stable coin. You will always need to incentivize pool liquidity, and for things that are finite supply by design, so things like Bitcoin or something like that, you're always going to be doing that. There's no other way around that. Is that right?
Yep. Yeah, for all native gas tokens, right? There's no contract thing like mint you ETH on another chain. So all gas tokens will always be wrapped assets. It just has to be that way, but everything else doesn't need to be. And actually, there's some hope for me that, I don't think there's a word I don't think it makes that much sense to have wrapped Solana on Phantom. Do we really need to have wrapped Solana on Phantom? Do we really need to care? What people want is to have exposure to the assets on Phantom, have exposure to credit there without losing underlying exposure to their SOL in that case. And so there's a world where lending protocols, and again, this is definitely happening, but there's a world where you can simply, let's say every chain has a pool of USDC, some stable, let's say USDC, and a native gas assets. You have ETH and USDC, Phantom and USDC, SOL and USDC, etc. And you can simply, through messaging, collateralize on chain A and borrow against that, take a credit position against it on chain B. So you stake your SOL on Solana, and then you take credit against it on Phantom. You do whatever you want in the Phantom ecosystem. You repay, it comes back, your collateral's unlocked. Why do we need to bring Sol to Phantom and Phantom to AVAX, right? It makes no sense for the majority. There are some corner cases where you might want to have some asset there to have a pricing and a DEX. Maybe you want to trade against the price of Solana on Phantom. And so then maybe you either need to have a derivative, you can have a perp, so you don't actually need to have underlying inventory. But for the large majority, like we don't need to have WETH on all of these chains. We could have people just collateralize ETH on Ethereum, send out a message, and borrow against that collateral position. And I think that is like a far cleaner.
Isn't that just sort of a wrapped token of a different description, that you're essentially issuing an IOU on a different ledger, which is kind of what a wrapped token is, right? So I stake Sol on one. Yeah, sorry, go on.
No. The general problem with wrapped assets is, okay, you use Ethereum. You use Uniswap. You're taking some risk of the underlying Uniswap code, right? But at the end of that, you never think about it again. At the end of that underlying transaction, you're done. With wrapped assets, you lock up an asset on chain A, you mint a synthetic IOU on chain B, and in perpetuity, as long as that IOU exists, the asset over there now carries risk. And there's risk that on the destination contract, if that is broken, infinite mint, now your underlying is worth nothing. There's risk on the underlying contract that is hacked and drained. Now your IOU is worth nothing. There's risk at the validation layer. There's all of these different layers of risk in the underlying asset existing on. So now we're to the point where you have, tens of billions of dollars of assets that are existing in all of these ecosystems carrying the risk. And so you have the ability to at least take some out of the asset. You still have these contracts that hold, you basically have Aave effectively across both chains. But there are so many mitigating factors that you can do to make that cleaner than what we're doing right now with wrapped assets.
Okay. So let's talk a little bit about sort of hacks and exploits, because obviously in the news today, there's been some pretty big hacks like Nomad, like Ronin, like Wormhole. As a non-technical user, how can you, in sort of like the simplest terms you can think of, how can someone understand why the LayerZero Stargate implementation combination is more secure than all of the other bridges that we're currently seeing sort of getting hacked?
Yeah, so I think there are a lot of things. One, there's like a list of things that I think people do poorly could do better, right? And so one of the things I think people do the worst is every contract for all of these systems are fully upgradable, which is literally complete and utter insanity. So there is no world that these should be. So in most of these systems, the contracts that are handling all of the parameterization, the contracts that are handling all of the security properties can be upgraded at any time by the underlying team. So no matter whatever fancy methodologies are being using. So, Nomad is a great example. So optimistic fraud proofs, people got very excited about this. I also think people wildly misunderstand the difference between optimistic messaging and optimistic rollups in terms of like Arbitrum and Optimism, because they're very different in actually the properties of how they're treated. But people got very excited about this. At the end of the day, the Nomad contract was fully upgradable, and this is not how they got hacked. But the Nomad team, whoever's uploading these things at any point in time, could have atomically set the the length of time that people could submit fraud proofs to 0 and submit a bad message and rug everything, because the contract was everything reduced down to that smart contract. And most of these other systems, everything reduces to contracts that are fully upgradable. So one, the LayerZero endpoints are 100% immutable. There is nothing that we can ever do to change them. And the way that we handle future proofing against things is we publish validation libraries. So we already have about 5. And let's say there's a world where you're on number 5 right now, and we publish a new one. We say, hey, new things have happened. This is 20% more gas efficient. You are not forced to move to that. And every other system, they push one update and everybody opts in. Good luck. Like, you have no chance. You're already done. You will not be moved.
They have to, because other systems rely on tokenomics to be able to protect the Sybil of the system, to protect the attacks. And so you couldn't have multiple versions of the same bridge.
No, you could technically. It would just be more work on the people who are their validation layer, whatever they're doing. And so, when we publish number 6, if you're a big application, you can wait 6 months. Let everybody else battle test it. You do not ever need to move. And this is part of the modularity we talked about in this Pareto frontier. You'll have different libraries. If state proof generation speeds up 1,000x, great. We'll have a ZK library. You could have an optimistic message library. You can have batch validation libraries. And so it is up to applications to opt into these. If they don't want to think about it, they can be on the default and they'll be auto moved to whatever is the default within the system. But we can never change any of the existing libraries or force anybody to move. So that's one thing. Upgradability, huge issue. Second thing is just audit practices. Again, I don't want to harp on the Nomad team too much, but they got one single audit. I've looked at it. It came back with about 40 issues. They did a single pass back through. Had nobody else audit after that point. 40 issues, and they just pushed it live, right? Which is pure insanity. So on our front, I think we've spent the most by a huge margin on audits. We're $3.5 million this year alone on audits. And that will be well over 5 million by the end of the year. We have 8 different audits. We've had 20-ish total. We have 8 more undergoing right now because we have Aptos, Solana, and Sui, which are all sort of undergoing the audit process. And so every single new endpoint we're launching on a chain goes through multiple rounds of audit, usually 3 or 4 totally different firms staggered. Even when we're launching new contracts, like the OFT standard, anything like this, rounds of audits. And so 1 is audit practice. 2, we have the largest bug bounty in the world in history. We have $15 million independently for both LayerZero and Stargate, totally separate bug bounties. And then the last thing is this concept of pre-crime. So people came from this world of everything being in an atomic state. So you were on Ethereum and you get your smart contract audited, but if it's broken, everything's gone, right? There's just a bug, people can execute it, it's gone. When you're going between chains, you lose atomicity, which sucks for some reasons, but there's some hidden benefits. And so you cannot have atomicity between blocks, between chains. You have this small amount of latency. Block resolves here. You need to get into the block over here. And so that gap provides a really interesting opportunity. And we built this thing we call pre-crime, which basically takes the state of whatever you're doing, takes the action, forks every chain locally, runs the state transition, and then allows every application to define its own set of invariants, and then checks the final state against that list of invariants. So what we use for Stargate, one of the invariants is solvency. If somebody is if this message, somebody, a hacker, whoever it is, has stuffed some clever bytes, or whether they're not, if this message says we're giving out $20 million on the other side, is the system still solvent? Do we get 20 million over here? Do all the numbers add up? Is the accounting there? And if it doesn't, then the message is not delivered, right? In a very simple thing, everybody watched the Nomad hack in slow motion. This was 2 hours. Hundreds of people were just slowly draining this thing. Everybody knew every single message going across was wrong, and there was nothing anybody could do about it. There was no way to stop it. And so that part is just insanity. That there are messages that are clearly, any observer sitting about could be oh no, that's clearly wrong. You're giving out, Axie Ronin, you're giving out $650 million here, and you don't have anything left. Right? There are very clear things that anybody look at it would be this is obvious. And that little bit of latency allows you to add systems like this. And so that is another thing that we did that has just been hugely successful. So we've had, billions and billions in TVL, billions of transacted volume, and never had any funds issued, nothing.
So this is I assume, so you guys have done this for yourselves on Stargate, and then are you seeing teams start to use this themselves when they're looking at using LayerZero? Are they starting to really understand that extra feature that's available?
Yeah, so especially we get, layer 1s, layer 2s, subnets, those sort of things. A lot of times are looking for a bridge, basically a bridge as a service, right? They're building a new ecosystem and they need to connect to everything else. And that is just a super low hanging fruit for, hey, if you're going to do this, the contracts are very clear, the invariants are very clear. So yeah, absolutely getting explored by tons of groups.
Okay, that's really, really cool. And so just in simple terms, one of the things that I think a lot of people don't understand, and in really good teams, you see it already, but I think that people don't talk about it, is this concept of upgradability of smart contracts. Why is Uniswap v1, Uniswap v2, and Uniswap v3 each a new version that still has liquidity and whatever. The reason is that the team has taken the decision to go, we shouldn't have the ability to arbitrarily move all liquidity simultaneously to a new version of the contract, because the risk that presents is basically now an admin key risk. If someone had the admin key, then they would be able to completely change the system. And what you're saying is that with LayerZero, that just isn't the case, and neither with Stargate as well. A lot of the problems that have been seen in these hacks do also have association with things like permissions escalation and stuff like that. So how does what you are doing prevent those kind of attacks where it is technically solvent, but the action itself is invalid?
Yeah. So like Harmony and Axie Ronin were both basically that, right? They had some permission set of keys that were responsible for their bridges. Those keys, through totally centralized means, their holders got hacked or whatever they are. So it wasn't actually breaking the system, but it was like abusing sort of the people who had the keys to mutate the system. And so I think that's the biggest thing, right? Uniswap, Uniswap came from the older school, and people have it's skewed a little bit, like the old ethos that the users should trust the code, don't trust anything else, right? And I think that is the ultimate goal, where Uniswap does not, if you LP on Uniswap, you're trusting the underlying code, but there is nothing that the Uniswap team can ever do to remove your LP, to change the state. You used to, there used to be 0% fee to withdraw, but now there's 100% and it goes to us. So you can never pull money, right? They can't do anything. They can't change the constraints of the system. And so I think that, I really think that is the biggest thing is we try to take every design decision that we make and say, hey, imagine that we were maximally adversarial, right? There's two things you want to protect against. One, our office blows up, all of us disappear from the face of the earth. Is the protocol dead? And that's one of the problems with existing systems, is most of these they're really services more than protocols. So we really harp on that. We want to be a protocol, not a service. If LayerZero, all of us disappear today, the protocol exists. There's nothing we can ever do to stop it. There's nothing we can ever do to censor it. Somebody else can pick up and start running relayers, oracles. Everything will resume. There will be zero gap there. We cannot stop it, period. And I think that's super, super important. We're Wormhole, any of these others, there is the ability for that small cluster to stop the wheel of time. You are opting into a service, they're providing a service, but it's not a protocol in the way that protocols are meant to be built. And then the other thing, on top of us disappearing, is assume that we are maximally adversarial. We want to ruin everybody. Do we have the ability to do that? No application should basically be reliant on that. And so that, that is basically how we think about every single decision and everything that we build.
Yeah, and I think this is, as you say, it's the old school from the crypto point of view, the old school crypto point of view. But I think it's sort of very much coming back around again. And that we tend to see that during down markets, is when people take an assessment of the rash decisions that were made during sort of bull season, when things are demanded to be done quickly and shortcuts are taken, and as a result you end up seeing sort of the retrospective. And it's good. It's how the industry grows and develops. So I mean, it's fantastic to hear that you guys are sort of in that school of thought, and really fascinating, both LayerZero and Stargate. So just to round this out, if any of our listeners want to find out more about what you guys are doing, what you are doing, how should they get started?
Yeah, I mean, I think if you're a developer, our docs are definitely the best place. In general, we're LayerZero Labs on Twitter and Stargate Finance on Twitter, but I'm readily available, so you will see me jawing away on Twitter pretty often. So I've been here a long time, and it's become a full-fledged addiction, so I will be around.
Brian, it's been such a pleasure having you on the show. Thank you so much.
Thank you.
More utility, then you better call on these guys. I'm going radical, I'm going Radix, I'm going radical, I'm going Radix. Hyperspeed DeFi, never on a decline, building the future, I feel like a savage.